Perhaps the first thing for the structural engineers to be aware of in his or her structural design is the assumptions and consideration of the design loads. As a structural engineer, we should be very careful assigning these loads in the structure we are designing for, because these loads will dictate how heavy our structure will be in order to achieve an economical design. After watching this video, you will learn at least the basics of load and its load path. What are the considerations in assigning loads in a structure, and the load calculation procedure necessary at the start of structural design. But before we proceed further, please subscribe if you haven't yet, and hit the notification bell to be updated with the latest video like this. We all know that a given structure carries gravity and resists horizontal or lateral loads. In this video, we will focus on the gravity loads that a structure is carrying. Loads in structures or buildings are composed of the self-weight of the structures, or the dead load, the superimposed dead load or SDL, and the live loads, or movable loads. These loads are the basic loads of a certain structure or building. These basic loads are carried by the slab, which will be distributed in beams and transfers to the columns to be resisted by the footing, which is rested to underlying soil. So how are these loads calculated? To understand how these loads are being calculated, let us know first what type of material that our structure will carry, and how we will differentiate each accordingly. In a typical residential concrete structure, for example, the load of the building is to be carried by slab. We will start our calculation from there. Dead load. Dead load is the self-weight of the structure. To calculate dead load, the density or unit weight of the structure should be multiplied by the thickness. That will give us the weight of the structure per given area. For a concrete slab of 0.25 meters thick, for example, that will give us the following. Considering unit weight of concrete to be 25 kilonewtons per cubic meter, 25 kilonewtons per cubic meter multiplied by 0.25 meters equals 6.25 kilonewtons per square meter. Superimposed dead load. Superimposed dead loads include the partition or interior walls, floor screed, floor finish, ceiling loads, facade and internal cladding, and MEP pipes and fixtures. To calculate, let us assume that a slab is carrying a total of 6 kilonewtons per square meter. Note that the same principle as calculating dead loads can also be adopted in determining the weight of the superimposed dead load, making up the construction, with the given density or unit weight of the material. These densities or unit weight of materials can be sourced from the relevant codes and standards, material data sheets, or obtained via laboratory testing. Live load. Live loads are the movable or moving loads that the structure can carry. It can include the movable equipment, movable partitions, furniture, and other people occupying the structure. Live load assumptions depend on the usage of the building or type of occupancy. It has obviously bigger live loads in an assembly or gym areas as compared to the residential areas. The minimum live load requirement is given in the codes and standard that we are using. Referring to ASCE 7-16, for example, Table 4.3-1 will give you all the recommended live loads of the structure being designed. Let's take the live load to the 2 kilonewton per square meter. So our live or imposed loads on a residential concrete structure can be summed up to dead load or self-weight 6.25 kilonewton per square meter, superimposed load 6 kilonewton per square meter, and live load 2 kilonewton per square meter. How the basic load is being distributed in the structure. Before we proceed, you have to differentiate whether our slab is a one-way or two-way slab. One-way slab transfers the imposed loads in one direction only, or in two edges to the perpendicular beam or walls. This tends to bend the slab in a short direction only. The two-way slab has 4 edges support. It is supported by beams or walls on all 4 sides, in which the bending occurs in 2 directions of the slab. To verify using calculations, we can see the following formula. For a one-way slab, we can consider a one-way slab if the ratio of the longer to the shorter span of the slab is greater than 2. And for two-way slabs, the ratio of longer to the shorter span of the slab is less than or equal to 2. Applying the formula for slab classification, let's now look at this slab framing layout as an example. To distribute the loads, let us consider the result of the loads that we previously calculated. Total dead loads, 12.25 kilonewtons per square meter. Total live load would be equal to 2 kilonewtons per square meter. The dead load, superimposed dead load, and live load that we consider will be carried by the slab. It will then be distributed to the perimeter beam supporting it. To distribute it on the perimeter beams, let's take a look at this figure. To distribute the load on a two-way slab, simply draw an isosceles triangle in its short direction, and a trapezoid in its long direction as shown. A one-way slab simply cuts the slab into two along its length. For the beam to carry the slab, calculate the areas adjacent to it. Let's calculate the loads on beams B3 and B4 respectively as an example. Area of triangle at B3 equals 1 square meter. Areas adjacent to B3 equal area of trapezoid plus area of rectangle equals 14 square meters. To distribute it along the beam, multiply these areas with the dead load, superimposed dead load, and live load to get the actual load distribution in kilonewton. Dividing the actual load distribution into the length of the beam will give you the uniformly distributed load in kilonewton per meter. To use and design, the service load should be multiplied by ULS factor 1.2 for dead loads and 1.6 for live loads. The load reactions on each support of the beam will be carried by the column joining them and eventually transferred to the footing supported by underlying soil. Visit our website linked in the description below to know more about the detailed calculations. What do you think about this video? Let us know your thoughts. Leave your comment below, please like, share, and subscribe for more. Thanks for watching.